everyone, and thank you to be here for this last talk of the day. Today we will talk together about platform engineering, love security, shift down to your platform, not left to your developer. I'm very proud to be here, and I'm here also with my friend and co-speaker, Matthew.
Hi everyone, I'm Mathieu Benoit, working for Humanitech, and I'm also a Cloud Native ambassador. I'm very glad to be here today.
Cool. A quick disclaimer before to start this talk. Any view or opinion expressed in this talk are only my opinion and not necessarily the opinion of my employer, its ownership, management, or employee. Okay, cool. Now let's deep dive into the agenda for today. We will have three main topics. The first one, we will talk together about the real security complexity in the cloud native world. In addition of that, Matthew will talk with you about what's platform engineering and all the aspects related to that. And finally, we will conclude this presentation with a series of actionable best practice to shift down and not to shift left. If you have any question, do not hesitate to interrupt us and ask your question. Security in the cloud native world. Currently, it's a big topic, but let me start from the beginning. I think it's important to start from the beginning and understand a security governance framework. You know, when a large company or large enterprise want to release a new cloud pattern, as security guys, we need to follow a series of steps. In this case, we have 6 main pillars. The first one, we will start with a security review. What is a security review? A security review, it's a technical document where we will highlight all the different security capability of one cloud services. For example, if we have an Azure storage account, maybe we want to enforce encryption, and we will enforce encryption with a CM key. That is a type of a security configuration we will highlight in the document. In addition of that, we will also highlight all the different threats and all the different security control we need to create to be sure our services is secure and compliant. And when that is done, we will do that for all the different cloud services of the pattern we want to release. We will move to the threat model. What is a threat model? In reality, in this case, it's a combination of of the mapping of the different link between the different cloud services, and we will try to identify which threat we have. And at the end, what we want to be sure is we want to be sure if we have the right security control in place to protect us. And after that, when the pattern is deployed in non-production, we will do a security assessment to be sure all the security controls are in place, and we are good with that. Fourth step, we will do a pen test, because sometimes it's great to have an external opinion, and sometimes that helps to find misconfiguration. And after that, we will do a scorecard. If you are not familiar with a scorecard, what is it? In this case, it's a risk assessment document that will help us to have a good idea about the security posture of our pattern. And the scorecard is fed by the different output from the security review, the threat model, and the cloud control validation. And at the end, the scorecard will create a risk score, and this risk score will be shared with the cloud governance board. In large organizations, the cloud governance board, sometimes you have the chief architect, you have the chief security officer, and you have also the different business teams. And the risk score will be shared, and in function of the risk appetite of the organization, they will take the action to move this application in production or not. That was to explain you what is a security governance framework to release a cloud pattern. As you have already seen, that is complex, that is also painful and very long if you don't have any automation. But now let me jump on the CNCF landscape for security and compliance. What I would like to also highlight with this slide with you is the number of different products to resolve a security problem. Sometimes it's also very challenging to find which product I need to choose, because sometimes we have some overlap of security capabilities, and that is a real challenge for the security team. But now let me let me deep dive. In this case, we are lucky because the CNCF releases a 4C security model. That is a model in four pillars, from code to cloud. That will help you to split your architecture and try to identify which security control and which threat you need to mitigate in four different layers. Just to highlight you the complexity, because today we are talking about Kubernetes. That is an extract of the OWASP top 10 with the different Kubernetes security challenge. As you can see on my screen here, we have a lot of challenge, and a lot of challenge are related to identity management, because that is not something easy to do in Kubernetes. We have also some challenge related to misconfiguration and how we can fix that. To give you another idea about the different threats we have, we are lucky because Microsoft help us and release a MITRE attack framework in this case, and that is only to give you an idea about the different threat for a Kubernetes platform. Now, I believe you understand the complexity, you understand the different security issue we can have, specifically if we don't have any automation in place. That's the reason why my coworker Matthew will help you to understand what is platform engineering and how the platform engineering can help you to resolve a security challenge.
Thank you, Max. So what we want to define is what's platform engineering, right? And platform engineering is not a new thing. It's very taking advantage and learnings from the past, right? So if you remember the sysadmin world where maybe we got the wall between the app developer and maybe the sysadmin deploying the package, we got this wall between the two persona, if we could say. DevOps came and said, no, we need to break and tear down the walls and make sure there is like maybe a seamless collaboration. DevOps came, and that's where developers were kind of doing the app development perspective, but as well was doing some infrastructure, maybe Kubernetes things, and maybe security things, right? So that's where we got this misunderstanding, misconception, if I could say, about the culture of DevOps. And that's where platform engineering is coming by saying, yeah, cool. Let's take the best of the two worlds and make sure now we have best practice seamless collaboration and automation around what we want at the end of the day, a better developer experience. How my developers in my company could ship code in production with quality, being compliant and secure, without dealing with all what Max was explaining, right? So platform engineering is very shifting down to the platform instead of shifting left too much on the cognitive load for the developer. And here it's coming from different perspectives. Yeah, as a developer, I want to ship faster. How I could drive automation if I'm more on the ops perspective in my company. Architects, I want more standardization, automation. For the CIO perspective, I want to accelerate the time to market, right? Deliver faster and better product for the end user to make more money at the end of the day. CISO, how I could be compliant, how I could enforce all what was discussed earlier. And why not having some cost saving, et cetera, et cetera. So let's focus on two main personas, the developer and the platform engineer. And again, the developer is here to develop product application without dealing with complexity of infrastructure. And let's say Kubernetes, maybe in our case. On the other hand, platform engineering is here to abstract and standardize as much as possible. But they are not alone, right? They are getting the help. They are now becoming the glue and the bridge between all the other very important key stakeholders, right? SRE, ops, cloud engineer, and security engineer as well. So at the end of the day, what we want is on the left side, as a developer, I want to focus on my inner loop. I want to focus on my code locally, maybe debugging my application. I want to code, right? And I want to commit in my Git repo and having some trigger of CI/CD, doing some continuous integration, and maybe deployment in ephemeral environment or graduating into a deployment pipeline. Then we will have this platform engineer layer, if I could say, where we could have layers to abstract, right, all of that, and not having developer doing Kubernetes and Terraform, for example. Why? because this layer in the middle is what will be able to abstract, standardize, and automate all these best practice in the cloud provider, in Terraform, management of database, et cetera, observability, injecting, right? So that's the end goal of platform engineering. Cool. Now let's talk about 6 actionable best practice to shift down and not shift left.
Yes, exactly, because a lot of people think in this case compliance can kill innovation, and security team can be, you know, a blocker for the business and a blocker for the different platform team. But now we will focus on 3 persona, you know, from the security engineer to the platform engineer to the developer. You know, that is an architecture extracted from the platform engineering CNCF document, and we will use that as reference. Okay, now if we start with the security engineer, you know, I believe in this case it's important to understand the goal and the responsibility of the security engineer in a platform engineering world. The first thing is a standardized configuration, because as security people, what we don't want to have is drift. We want to prevent drift. And for that, we need to enforce standardization and configuration, specifically if we have regulation and if we need to be compliant with regulation like PCI DSS, for example, if you manage credit card, or IPA if you are in the healthcare industry. And after that, the second pillar will be scaling security best practice, because yes, it's great to enforce security measure when you have 10 clusters, but at the end, when you have 1,000, 5,000, or 10,000 clusters, it's another story. Reducing the attack surface. Yes, that is because also you want to limit your external surface, and you want to protect your infrastructure. Versatility and preventing privilege grip. The last one is not the least, because from what we can see from the market, a lot of attacks are coming from identity when the identity are compromised, and that is very important to understand that. My first tip and my first recommendation, maybe you are already aware, maybe you are doing that, is scan everywhere, is scan everything. You know, start from the infrastructure as code, and after that, start to scan your code source. You can leverage tools like Checkov, Kix. Lot of open source tools can help you, and you will be surprised about the different misconfiguration you will find. That could be some network security group misconfigure, or maybe you have some hard-coded token or secret in your code source. I'm sure you have that, and you don't want to say that. After that, another important topic is to scan your container image, because as we have already said before, we want to reduce the attack surface in this case, and to reduce the attack surface, we need to have a small container and also updated container. And after that, compliance control. Compliance control is something I will recommend you to start from day one, because it's very, very important to specifically if you need to follow regulation to be onboarded with the compliance at your architecture design level. And for that, you can enforce open policy agent, Kyverno policy. That is only a few examples. And runtime security monitoring, because it's great to have hardened Kubernetes cluster, but in reality, if you don't monitor the different behavior of your pod, of what happened inside your cluster, you will have a big lack of visibility. And if your cluster is compromised, maybe you don't know that. My second tip is related to shift down preventing misconfiguration with security control for regulated organization. This one is because, you know, lot of organization when they start to enforce security control, they start with detective control, and after that they start to enforce preventive control. When they start to enforce preventive control, they will have more friction and more friction by the different team. And at the end, they put auto remediation, because, you know, when a control fail, when you have a misconfiguration detected, you want to have a logic to automatically patch that. But that will not resolve the issue for the developer, because when the developer will create this code and will try to push the code, it will be blocked at the first gate. In this case, what we want to do is we want to give early feedback to the developer, and for that it's possible, for example, if you are leveraging OPA policy, to run the OPA policy locally and to have check also directly in your commit and provide an early feedback to the developer. And that will reduce the friction, and that also will help your developer to deliver secure code faster.
Now let's move to the platform engineer role, right? It was more on the security engineer role. Here it's a zoom on this architecture diagram from the CNCF platform white paper. And here they are talking, I love that, about platform capabilities. As platform engineer, how I could expose interfaces and capabilities of my platform, right, to my developer. So I really love this approach because it's very here where you will think about designing and developing stuff on top of Kubernetes, but how you will simplify the life of the developer, right? Which feature do you want to provide, and how you will provide. So the tip number 3 is about CI/CD. There is a huge opportunity for platform engineer to just take best practices and try to automate, standardize CI/CD pipeline, right? Here we are taking an extract of another white paper from CNCF, the security white paper, where they focus on distribution, right? How I could do continuous integration. And if you look at all the layers, are we asking the developer to do that? Maybe, but at the end of the day, you shouldn't, right? Because after that, there is this CI and now the CD part, how I distribute, how I deploy, right? So what I want to cover here is at each layer, as platform engineer, you could ask you how I could, again, shift down to maybe template of my CI/CD pipeline or to the platform I'm using, and not asking my developer to have that and coding that, right? So for example, a lot of talks were about security today. I'm very glad about that. And for example, how I could decrease the CVE fatigue, having some distro-less container base, right, with chain guard. How I could also simplify the writing of Docker files. I don't know if some of you are using build packs, but that could be a good opportunity to not having a Docker files, because writing a Docker files could be complex, right? There is some security hardening already here. Are we asking a backend and front-end developer to write a Docker file? Maybe you will have template. Maybe you will have some documentation, and maybe some automation. Another part could be what Max mentioned, is about failing fast as soon as possible. Again, you could use Docker Compose, for example, or you could use Minikube or Kind, and instead of waiting hours or days to deploy actually the brand new application or version of the container, you could run that in CI pipeline, right? Why not just failing fast? Hey, your container is not running. Fail fast, fix, and we will move forward after that, right? So all these checkpoints are very important and are very easy to automate. Are we asking the developer to do that? Maybe not, right? Scanning the container and the packages, Trivi and from Aqua and other tools out there. What I love is what Max mentioned. I don't know if you're familiar with Gator, a CLI for OPA Gatekeeper, or Kyverno CLI. You are not, it's not mandatory to wait for the admission controller in Kubernetes to say that, let's say, the Kubernetes manifest are not compliant. You could run that in your CI pipeline, right? If you have the render manifest, you could use the CLI to see the enforcement with the policies that you want in your cluster. But you are not waiting the admission controller to tell you. You could fix that and actually enforce this kind of policy earlier. Another one could be signing. If you know Notary, if you know Sigstore, you could sign the provenance of your container, packages as well. And then you will move to the stack and having more automation around CD, continuous deployment. One of the, there is multiple tools out there, GitHub Action, GitLab, Jenkins, and other. You could also use some GitOps tool out there, Argo CD, Flux CD, in order to deploy your container and your manifest. Here you will have how I guarantee the provenance of my container, and why not my artifact here, again, with Sigstore and Notary. On the other hand, I will have also the enforcement of the policies actually in my Kubernetes cluster. And here, for example, I could use also mutating webhook to inject, for example, the label of PSS, pod security standard, enforcement in my namespace, having a restricted security context, right? And why not injecting network policy with Cilium network policy or Calico, and having some injection of MTLS communication between workloads and authorization, right? All of that shouldn't be something your developer should deal with, right? That's why the platform engineer could inject at any layers complexity and a very important security feature. Tip number 4 is about another opportunity you have as a platform engineer. I don't know if you have seen this talk from Daniel Bryant, taking this Gartner diagram where there is 3 layers. At the top, application choreography. At the bottom, infrastructure. In the middle, that's the missing pieces on top of Kubernetes. If you look at Joe, Kelsey, and others in the industry, they said that Kubernetes is the platform to build platforms, right? And that's the opportunity here. What about using some orchestrator on top of that to facilitate the coordination, the deployment between application and infrastructure? If you know Crossplane, you could deal with composition and the provider. If you know Cratix, the promises and the workflow. If you know Radius, you could use recipes to bind all of that. And on a more commercial aspect, Humanitech, resource definition, and driver. All of them will be able to orchestrate both application and infrastructure. On a developer standpoint, I will go faster here. We want to abstract as much as possible. So as an end user, developer of my platform, here I'm using score file in order to describe how I want to and what I want to deploy for my container to be running in a platform, right? Here I'm using, I'm just describing how to do that. I know that I will have a DNS to expose my workload, and I want a Redis Dapper state store. I don't know if you're familiar with Dapper, but here you have an opportunity to have your developer not writing Kubernetes manifest. If you leverage Dapper, they don't know the infrastructure. They could use an interface to abstract the infrastructure. And let's say you don't want to write Docker files. You have an opportunity also to abstract this part. On a abstraction layer, a portal is very important. That's the interface and the front end of your platform, where you will be able to centralize documentation, scaffolding, onboarding template, as well as a centralized way to manage where are my workload and project running, what are the status of them, et cetera, et cetera. So that's pretty much the wrap. We went through the different layers from the CNCF security white paper here. Very complex, but we have seen also that the goal is to have a more velocity for the developer, more stability on the platform engineering and the other stakeholder associated to that with the platform. But also you need to remind that you need to have a product mindset in order to have this contract and interfaces between your developer and the platform. Again, the developer are very focused on innovation and creativity instead of dealing with all what we presented, right? There is this maturity model from the CNCF platform working group, which is showing you where you could be at and how you could improve maybe, and some tips how to improve and becoming more mature with your platform. Again, what we really enjoy is having Kubernetes upstream, showing such security shifting down to Kubernetes, where you could see now validating admission policy built in Kubernetes. You have also the gateway API, where you have a segmentation, let's say, a collaboration between all the stakeholders we mentioned, security, platform. And we could see that network policy are coming upstream more and more to collaborate more between admin and security and platform engineer. So that's very a shift down from Kubernetes itself, which is good. We have a lot of references here. You could scan this QR code. That's the link of this PDF version. Yeah, thank you for being here in this last talk of the day. Thank you for being here.
Any question?
Any questions?
Yes, yes.
Thanks. This was great. Just a lot of great ideas here. I work at an organization where we have a Kubernetes platform. Our tenants range from I just have an app and I want to deploy it to I'm bringing my own CI/CD pipeline. I'm bringing my own container templates. I'm bringing my own stuff. I just want a bare API, get out of the way. And we find ourselves often in the middle of how opinionated should we be in order to save developers from themselves while still giving them the flexibility to be able to innovate and produce products? Out of all these ideas, what do you think, what's your kind of top idea of this really should be part of the platform? This shouldn't be left up to the developers. This really should be something that is decided on from a security perspective just to save us from ourselves, basically.
Yeah. I think it could be a long answer. I could take
exactly.
It could be a long answer, but I mean, we provided some very quick win, and pod security standard is one of the most easiest tips you could have. You just enable restricted on the namespace, any container non-compliant, privilege mode, running as root, and having write access on system file. Could be a good deal with, hey, it's broken, fix it, right? Mm-hmm. So you will learn a lot, and all of that, it's not day zero. Yeah. You need to be very agile, right? And you should take one security control and making sure, okay, now what we do with that, right? Distroless container image to just decrease the fatigue of security threat and managing the CVE update. So at the end of the day, it's each organization, you will see where you spend the more money, the more time, and how you could have quick win to improve the security posture, right?
And to do that, if I can add, because sometimes I can understand it's very challenging if we need to invest a lot of money and time to do runtime detection, for example, or security control or stuff like that. But to take this decision, that should come from the output of the threat model. When you will do the threat model of your pattern, in the output of that will be, okay, we have this list of threats, we have this list of threat actor, because that will depend about the size of the organization, what you are currently doing. You will not have the same threat actors. That could be an insider, that could be also another foreign country who can try to attack you. And the output of that should feed your strategic plan to say, okay, now I will start to put maybe a strong emphasis on runtime detection, because we believe maybe for this critical app, maybe we have some insider and we want to have alert about that, and we will onboard the SOC team. That is my recommendation. It's very challenging to take a decision, say, okay, now I invest on distroless. Okay, it's great, but maybe in reality, maybe you have some other priority. And the security priority in this case should not be driven by tech trip, if I can say that, but should drive from the business need. What the business need to deliver, and in function of that should fill your security roadmap.
Great, thank you very much.
You're welcome.
And I think to add on that, that's a key role here. It's very important. Why? Because they are doing the bridge, right? And it's not a silo. It's, okay, let's have a product roadmap. What's your roadmap here? What's the problem? Oh, you want to enforce to those guys? There are thousands of developers, and you want to inject in their M-chart security context and the distroless base image in all their container. They will do that. They need to deliver to the business. They don't care. So how this guy could automate and understand the reality? We need to do that. But how? And those guys are here paid. That's a brand new team now, right? Yeah. And they have the bandwidth, the innovation, the budget to, okay, let's figure it out, right? So I think, to your point, those guys will have priority in the backlog in order to make sure it's compliant, but those guys are not going down in the velocity, right? And innovation.
Yeah.
And does that make sense?
Yeah.
Any more questions?
Hi, so that was a great talk on platform engineering, but
you kind of talked about shifting all that cognitive load down onto the platform team instead of left to the developers. What about a platform as a product type approach, and thinking about a collaboration model for actually creating some of these products, capabilities, rather than pushing it all onto the platform engineers? What's your thoughts there?
Yeah, go ahead if you want.
And just to make sure, sorry, I didn't hear correctly. Is it more on the platform as a project?
So you didn't mention platform as a product at all.
Yeah.
You just talked about platform engineering. So what are your thoughts? Because you started to go into it there at the end, but you didn't mention it at all.
Yes, and you're right. And the talk is very mostly on security. And look at the presentation from Max. He's a security expert. There is a lot, right? So I think the point, and that's a good point, this guy should very be focused on as a product for this guy, right? And here we didn't cover that. But what we cover is if you have this platform as a product mindset, how you can abstract, right? And have the interface with this guy, because they need to understand the reality. What's your CI/CD tool? What's your application? Oh, okay, you are Java, and you need to talk to MySQL and things like this. Oh, okay, so we will supporting this golden path or use cases. And you see, so you're right, we didn't mention that. But this guy should expose the well-supported golden path and use cases, and after that, mapping that in the security control and automation we discussed. So we didn't cover that exactly, but that's the intent here, right?
And if you have an application with regulation, sometimes from what we can see from the market, it's a real disconnect from the product team to the security team. And because in this case, all the security need should come from the regulation you should to follow, and that is why in my presentation I said it's important to include that from day one. When you are starting to designing your application, try to be sure you will support all the need from the regulator, and that is something very important, because at the end, if not, you will hit some blocker from the security team which say, okay, yeah, now for example we have I can give you a real example. For example, in PCI DSS you have some requirement to have minimum TLS 1.2 communication in place for all the different components. But in your case, maybe in your application you have some unencrypted communication between pod on the same namespace, but the security team will say you, hey, in this case you will fail. You will fail. You need to modify your design to put this TLS encryption in place. That is just a quick and simple example, but that demonstrates one challenge, and that was the conclusion also of this talk is collaboration. If you have a strong collaboration from day one with the different actor, you will be able to deliver at the end a better experience to your customer.
When I just add something, 2 days ago I had a talk with a large German company, and they're also going to shift. Everything is clear. Worked with the people who are already technical, they come up with some stuff and so on. But what I found out when we talked with them, first, it's not easy to get this mindset in, and second, they just missed a role of a product owner. They didn't realize now they become a product team and they have to treat infrastructure or their service as a product. And then you sit with people who are very good technically, come already up with some POCs of crossplane, and then you're like, where is your product owner? You know what I mean? To who I need to talk now on a non-technical level to find out how to talk with the other ones. So yeah, it's not that easy sometimes from a slide to the real life, because
not easy, but very important.
Yeah.
Thank you. Nice presentation, insightful. Okay, earlier we had Linux system administrators. Forget about Linux, system administrators. Now the equivalent of them, I'm seeing platform engineer and a SRE and a cloud engineer. So now, is there a place where I can find out like what is the clear-cut definitions of what are these roles and what are the differences, like which is not overlapping? Can you elaborate a little bit, or at least point me to somewhere where I can know what is their roles and responsibilities and their separation?
Yeah, exactly. Cool. Thank you for the question. Platform engineering is not new, and DevOps is not dead, right? Why? Because at the end of the day, you have already all of that in your company, pretty much sure. kind of, right? You have cloud engineer, security engineer, and some people maybe SRE, observability, right? All of them are existing. The issue we have today is those people don't have the bandwidth, the time, the energy, and name it, to actually talk to those people here, thousands of developers, doing shadow IT, doing Helm, customize, Java, Docker, whatever, right? And here they are like, okay, we cannot deal with that, and we are blocking now, right? So platform engineering is saying, okay, we need a new team, a new role, doing the bridge between both of them. Those people are often coming from two worlds. You will create this team based on their developer background, so you will have some developer here, and you will have some people from here in there. Those people know the reality for both worlds. And the goal, to his point over there, is this guy will have the product, so the platform as a product mindset. How we could simplify this life and make sure we guarantee that those guys are satisfied by them, right? So it's a layer of abstraction. So it's a brand new role combined with very existing experience, right? And they know the reality. Now they have time, they have budget to actually, I don't know, create a tool, create a wiki page, create whatever to answer the most pain point in order to iterate in their product and say, okay, point 2 now, let's resolve how we could do that, right? So this team is very kind of brand new, but just having the experience and the time and the money to actually resolve issue, to innovate while being compliant. So I don't know if it helps. Does it clarify a little bit, or?
Yeah. I mean, it helps me, thanks. But then, just to understand, is the cloud engineer only looks at the cloud infrastructure and SRE looks at from the application point of view?
So that's a good point. But here, you will have a lot of platforms, right? Because the reality, do you have everyone running in cloud and in Kubernetes? No. So here you will have VM, on-prem, you name it, right? You have all the stakeholders. And this guy will be, again, the interface with this guy and say, okay, we understand how to deploy there, how to leverage your tool. Please give me the recipe, and I will automate that. So those guys are very like collaborating with both sides in order to put standardization and automation, right? They are not replacing. They are just applying recipes from them.
And you know, for a security team, it's very important to have that, you know, because when we work with the platform engineering team, when they will, for example, create, I don't know, a sample, a POC or a sample of deployment to an application team, they will be sure, in my case, all my security control will be compliant from day one, you know, and I will not have the effort to work with the application team to do all the remediation, all the follow-up, all this painful process, you know, when the security team are not coming from day one. But in this case, with that, I can have an hardened template compliant at 100% from day one, and that is very great for us. Yeah. You're welcome.
Hey, thanks for this presentation. And following up on what he said, just giving like an actual example. So let's say the developer is coming up with a container image, okay? And then there's a whole bunch of libraries or whatever they're using, and one of it is the most latest and greatest version of, say, Terraform or something, and it's got a vulnerability. And on this side, you have this cloud where you can't afford to run that kind of image in the cloud because that vulnerability might just take down the service. So you're saying, like, let's say the platform engineer here is kind of like the bridge between the developer and the cloud, saying that we need to put some processes so that, hey, you cannot use this latest Terraform feature, but you gotta, downgrade because these guys cannot. Is that a good example?
That's a good example. And the guy over there asked, hey, I have people who would like to be very abstracted. They just want to ship code. And I have another kind of developer who would like to do Kubernetes and Terraform still. Yes, you will have both. But let's take the dream, where I'm a developer. I'm just focusing on my code. I don't even touch Dockerfile, right? This guy will allow in CI/CD pipeline to inject the Dockerfile, whatever, build pack or whatever, build the container. So all of them will provide a template. They don't know that. And here they will run Docker Compose. Oh, it's not running. Fix your application. Oh, it's running. Let's continue. Deploy on a kind cluster locally, right? Oh, and after that, I could scan. Oh, it's not working. Fail fast. And you see all of that is template that this guy will do. Now, oh, you have an application and you are in this POC project? Cool, let's do this. We will go in Azure, boom. Or you are this highly standard, I don't know, regulated project. We will decide to route you here, whatever. You see? So that's an abstraction. The dream is to have the abstraction of this guy writing automation and decision based on the context.
Yeah.
And just abstracting all of that. Because after that, you deploy, let's say, do you know Helm? Helm chart? So at the end of the day, you could ask your developer to create the Helm chart, maintain the Helm chart, or you could say, no, we have an Helm chart over there, just fill out the values. The end goal is to have a minimum values. The Helm chart is abstracted. And here, this guy is talking to the security. Yeah. Oh, I need to inject this security context, unprivileged, non-root, add the label, add Istio MTLS, add whatever. This guy will automate all of that. They don't know. They shouldn't know.
Yeah.
So you see the layers of injection.
Yeah. And also from the cloud side, it's impossible to keep patching every single thing with so many people with different versions.
Yeah, exactly.
So I think it's a real pain over here. So
yeah. And here you could add, are you familiar with workload identity? On Kubernetes, if you have a workload talking to a cloud SQL database, wherever it is, you want security networking, right? So you have the recipe, but this guy will help you to inject that.
Yeah,
based on the
that will
Terraform
save
script. That's
time.
not this guy doing that.
Yeah.
And when I presented the security engineer, in the goal and responsibility, one pillar was standardization, And if you, for example, to make a link with your example, if you provide hardened base image, hardened container-based image directly to your developer, in this case, they will not come with a funny other container image pulled from you don't know where, and that will introduce vulnerability. Now, if we step back and currently it's easy to provide image to your developer, hardened image. The challenge you will have when you will work with third-party solution. For example, if you have in your Kubernetes cluster a telemetry solution deploy or any other third-party solution, because the vendor, in this case, they don't want to use your base image, and you need to take the time to create exclusion about that, to be sure you have a runtime security monitoring in place specifically for this image, because you don't manage this image, and this image was not built from your rules. And that is also in terms of threat, that is also very important. We are seeing a lot of cluster compromission, not with third-party solution, and I will encourage you to do that. And another best practice in this case, and what a lot of companies are doing is, if you can isolate all the third-party solution to another cluster directly, that is also something of very great to do. To have like a utility cluster,
Thanks.
Any question? I just want to give a remark on, Mathieu did not mention this, and I'm not a kingmaker, but I really like SCORE, so I highly recommend everybody to have a look into SCORE. If it helps you, it's a really nice approach, but I'm not a kingmaker, so I just mentioned it.
And tomorrow, Mathieu will do a demo of SCORE.
Okay, that's then join this talk because it's interesting. You wanted to?
There's a time I will ask one more question.
Yeah, sure.
Okay, this is my point of view, just correct me if it is right. So platform engineer abstract everything for the developer, and the cloud engineer is abstracting everything in the cloud. And SRE's job is to ensure the users are happy, the applications from the user's point of view are good. Have I summarized correctly?
Yes.
Yes. Yes. Yes.
But
but those guys have recipes. They have recipes in place. But the point, so you're right, but the point is between the intent I want to deploy to actually deploy, in the middle, someone or automation tool need to inject these recipes. So the point is to say, okay, you will help them to inject at the right time, at the right moment, at the right tool, our recipes. You will help us. You see you're right, but it's on top of that, right?
Okay. Thank you.
Because what I love, so I will add something because it's very important what you said. We always say developer experience with platform engineer, right? And platform as a product. But look at that. The developer is here, the customer is here, the product is kind of here. But guess what? Here, you have other customer. They are partner. They are your key internal stakeholder. But at the end of the day, they are also your customer. So always we talk about this developer experience, but what about this guy? Yeah. Right? Because if you are not helping the SRE with injecting the right tool at the right moment, if you don't understand their reality, how they will debug in production? Oh yeah, but we simplified the life of the developer. But yeah, but you added a mess for us, right? So you see, and that's not easy, but that's very important. So you see the point here?
Yes, thank you. But then both of you spoke about large organizations where thousands of developers are there. So maybe they can afford to have a dozen platform engineer, a dozen cloud engineer, and a dozen SRE. But how about small and medium enterprise where maybe there's one or two DevOps engineer in the whole company? That one person is the cloud engineer, or maybe three people is a cloud engineer and platform engineer, and every operations job they have to do, right?
Yeah. So it doesn't work for small business. If you are a startup with one developer, to exaggerate, one unicorn DevOps developer full stack doing front-end to Terraform, it doesn't work. You have one person. It's at scale. We are talking about hundreds, thousands of developers, right? So you need a certain maturity with a real pain point that you want to address with this kind of model. So that's a really good point. Yeah.
We need to wrap up now, Max and Mathieu. That was really great. You see,
thank you very much for the question.
Thank you.
There's drinks and all the stuff for everybody. So yeah.
Yeah.
Thanks.
Thank you. Thank you so much.